Okay, we're going to go ahead and get started. Hello, and welcome to NOAA's National Ocean Service Science Seminar Series. My name is Tracy Gill, and I'm the coordinator for this series. We have partnered with the U.S. Global Change Research Program, or USGCRP, on a special seminar series on the 4th National Climate Assessment. And my co-host on this series is Katie Reeves, Engagement and Communications Lead for the USGCRP National Coordination Office. I will provide a few seminar logistics, and then Katie will introduce the seminar and speakers. Here are the logistics. There are 2 presenters today, so we will allow a few questions after the first talk as long as we can start the second talk at 1:30 to give time for the second presentation. Then we can have additional questions for both speakers after the second talk. Please type all questions into the chat box. If you are interested in getting a PDF copy or recording of today's presentation, Katie will list the relevant websites in the chat box, or you can contact me, Tracy Gill, or Katie Reeves, and our emails will be in the chat box. If you are not on NOAA's weekly science seminar list but you'd like to be, please email me at tracy.gill@noaa.gov and I will add you to the list. Folks in the room, please sign in and silence your phone. And now Katie Reeves will introduce the seminar and speakers. Katie?
Great. Thank you, Tracy, and thank you to NOAA for hosting all 11 installments of this webinar series that have been focused on the findings of the 4th National Climate Assessment. We are really appreciative of NOAA for lending its platform to us and for all of Tracy's hard work on this. I'm Katie Reeves, the Engagement and Communications Lead for the U.S. Global Change Research Program, or USGCRP. The Global Change Research Act of 1990 mandates that USGCRP assists the nation and the world to understand, assess, predict, and respond to human-induced and natural processes of global change. And one way that we do that is through the development of a quadrennial national climate assessment. The 4th assessment was released in 2 volumes. The first, the Climate Science Special Report, was released in November of 2017, and it was covered in an earlier webinar series, which can be found on our website. I've just listed the link in the chat box. The second volume, Impacts, Risks, and Adaptation in the United States, is the focus of this series. So as the title indicates, NCA4 Volume 2 assesses the observed and projected impacts of climate change across the U.S., covering 17 national-level topics in 10 regions. The assessment was released in November of 2018, and you can read and download it at nca2018.globalchange.gov. Today, I'm really pleased to welcome Roger Pulwarty and Jeremy Martinich as they present on actions to reduce risks in a changing climate, findings from the 4th National Climate Assessment. Dr. Roger Pulwarty is the senior scientist at the NOAA Physical Sciences Division in Boulder, Colorado. His publications focus on weather, water, and climate extremes and risk management in the U.S., Latin America, and the Caribbean. He has also helped develop and lead widely recognized programs linking science and services, including the National Integrated Drought Information System, the Regional Integrated Sciences and Assessments, and the World Meteorological Organization Climate Services Information System. In addition to his work on NCA4, Roger has been a convening lead author on the UN International Strategy for Disaster Reduction and the IPCC Working Group 2 on Impacts, Adaptation, and Vulnerability. Today's second presenter, Jeremy Martinich, is a climate scientist with EPA's Climate Change Division. He coordinates the Climate Change Impacts and Risk Analysis, or CIRA project, which is a multi-team modeling project to estimate and monetize the risks of climate change to U.S. sectors. And Jeremy led the development of NCA4 Chapter 29, Reducing Risks Through Emissions Mitigation. Thank you both for joining us for today's NOAA Science Seminar, and I will turn it over to you, Roger.
Thank you very much, Katie. Thanks, everyone, for organizing this, and let's get started. What I'm going to address is mainly the results of Chapter 28, Reducing Risk, and with some additional information that has come to bear on how we address issues surrounding adaptation. The leads from this you can see at the bottom, Rob Lemper, Jeff Arnold, and the entire gang. Quite a diverse group we had from the private sector, public sector, NGOs, and consultancies, and academia. My role here was, I was the CLA on Chapter 28, this chapter, a lead author on water, and a lead author on the Caribbean, as just mentioned. So as we think through these issues, we go to the first slide, and this, I will, in fact, treat this presentation, this being one of the last ones with Jeremy, as syntheses of where we are and align those in the way that we think about adaptation. We're familiar with this slide. It's been seen everywhere in terms of the climate change indicators and the trends therein, so we know the changes in the data. We also know that spatially it's very uneven. Issues surrounding wetter conditions in the east, possibly dry in the southwest, land and water changes, oceans and coasts. And so the question is, where does that leave us, knowing that this all comes from the first part of the NCA4? The question is, we have many potential futures, but some sense of where they're going. And adaptation requires science that assesses dynamic risks, or decisions, or vulnerabilities. Very clearly has to improve foresight, but we have a fundamental question about does foresight become action? And so where does that leave us from the standpoint of individuals and societies? Which pathways should we take based on what information, and when should we change our assumptions? And this is very fundamental in the context of what I'm going to talk about as to where and what we're doing on adaptation within the United States, and then some of the challenges that remain that we may try to overcome. So just fundamentally, we know, and to keep this in mind, the links across multiple sectors, of course, the systemic view of climate and of climate impacts is becoming more and more prevalent. We know there are issues surrounding what we call regular everyday policy making and decision making, such as operating reservoirs, operating transportation systems, but then also this question about how biodiversity, aquatic ecosystems, and terrestrial ecosystem services affect human well-being. So I want us to keep both of those things in mind, the fact that we have to deal with what is considered to be the everyday decisions of how our systems operate, and then also the questions surrounding the long-term risk of interacting systems and the complexities therein, the changing interactions and emergent properties, and the ways in which those regulate our services. So just as a quick overview, as I mentioned, part of this, a big part of my presentation is aligning things you will have seen under the context of what we have in the adaptation chapter. There's some examples in the coastal arena on impacts and adaptation efforts, impacts on recurrent flooding, sea level rise in the southeast, all the way down to coastal erosion in the U.S. Caribbean, and multiple stresses in the U.S. affiliated Pacific Islands, and then some efforts that have been undertaken in those contexts. So, of course, I don't expect you to read all of this. This is in the report, but it's to give us a sense that many things are happening around the region and around the United States, and the question is, what are we learning from them, what is being scaled up, and where might we take some of these ideas forward? So the key message number one is adaptation implementation is increasing. Activities are occurring throughout the United States. If I were to talk about this as we did in the previous national climate assessment and the ones before that, a heavy focus on extremes, there would be a lot more weighting on adaptation planning is taking place, but very little implementation. At this time, we're actually seeing more implementation activities in the public, private, and nonprofit sectors, but I'll come back to the scale of those, the ways in which economies, communities, and the environment are being put together in the context of adaptation. One example of those we can see from the Community Relocation Project in Louisiana. A grant is being used to relocate the tribal community of Ile de Jean Charles in Louisiana in response to land loss. So that's one type of adaptation. And how that becomes acceptable, how that type of action preserves the dignity of the people involved is a key part of the question surrounding adaptation, which is much beyond what the impacts are. Another is in Kivalina, the rock revetment installed in the Alaskan Native village of Kivalina with a lifespan of about 15 to 20 years. And so we begin to ask the question, do we live with risk? Do we do triage? Do we move? Or do we begin to understand how to manage a changing environment in the places in which we live? Another way in which we're thinking about Swirl in the city of Norfolk, designing the coastal community of the future, envisioning the future. We have some examples of these and very familiar ones that have been brought out by the Department of Housing and Urban Development National Disaster Resilience Competition, a design-driven approach for local resilience envisioning and planning. So how we think about where areas for priority of adaptation is needed, urban centers, the neighborhoods of the future, the planning we need to do over the next 30 years for new infrastructure, including the things that we're doing with present, becomes a way of envisioning a future that we want to play a role in influencing. So it becomes a very critical way of thinking about adaptation planning, and of course the Indigenous Peoples Climate Initiatives and Plans, and I've mentioned a couple of those earlier, but the issue is this is becoming more and more systematic in the context of not just how Indigenous people are impacted, but the contributions they themselves make to helping us understand the movement of the seasons and how we respond, and the insights that they bring to helping us adapt to a changing environment. So we're responding to the impacts of climate change around the country in different ways, from the Northwest to the US Caribbean up to the Midwest. This map shows some of the impacts that have occurred and some of the response actions since the third National Climate Assessment. They're not indicative, as I'm wanted to make the point, of just where the biggest priorities are, but just to give you a sense that, in fact, things are happening around the country, around the territories, and there are ways of learning from these. The question is, how do these get scaled up? What are we learning from them, and how are they evaluated over time? So implementation has increased, but we wouldn't say that it is yet commonplace. So the second key message is successful adaptation has been hindered by the assumption that climate conditions are and will be similar to those in the past. As every climate scientist could tell you, this is like rediscovering unsliced bread. We've always known that climate is changing. We've known that it's varying over time. Our statistics and what we use for planning, however, assume stationarity. It's not that we assume climate was stationary. But we know by increasing the incorporation of information on current and future climate conditions into our design guidelines, we might be able to manage some part of that risk. So as we go through this and we take the complexities of vulnerabilities and adaptation, ask, okay, there's increasing wildfire burn in some areas, drought severity, lowest snowpack, lowest stream flows. To increase resilience to future stresses and disturbances, we have some cases of adaptation options, but we're not yet fully cognizant of how we manage the complexities of interacting and compound risks. We do know how to handle things concerning wildfires, but when that is combined with increasing drought severity, that becomes a surprise in the system. So where does that leave us? Excuse me. We have a set of options in different parts of the country where we're learning about how disaster risk reduction helps inform climate adaptation over time. So we're trying to link in the adaptation community much more clearly to the other sectors that are managing and mitigating risks in changes in systems that affect adaptation. And here are some examples of those: the prescribed burning, the use of natural areas to absorb and channel floods, commercial fish species changes and how we manage and map those, and wildlife rangeland management. That becomes the way in which we think about systems and how they feed into adaptation as both a process and an outcome. Some of those changes are faster than our institutions are accustomed to respond. There's one picture on the genetic diversity and climate exposure in the Pacific Northwest, primarily the Columbia River Basin, and the main point of this is that the way in which changes are occurring and the rates at which they're occurring are, in fact, in many cases, both in the physical system, in the natural system, and in the human system, faster than the rates in which our institutions accustomed them to respond. So when we say things like, well, yeah, there was sea level rise in New York 100 years ago and we adapted over time, that was the point. We adapted and adjusted over time. And the question is, are the rates of change overwhelming even the emphasis on the directions of change? And that's an old statement concerning how we plan from event to event. And so that's what we'll start talking about. Societal options for resource allocation. We have limited resources to help individuals and communities adapt to climate change. And at the end, I'll say kind of why that is. And this remains one of our challenges with trying to work with our individuals, our institutions, on being able to adapt and adjust, at least at the rate at which things are changing. This does not necessarily include the potential for thresholds and surprises over time. Another aspect that complicates adaptation, but in which we're constantly trying to work, is how our systems interact. Energy, water, and land. Example, electricity and infrastructure failures, being linked to things like water demand, less water availability for electricity generation, and we can take those issues and ask how do complex risks then filter into our adaptation plans. So this is an interesting dynamic that gives us a sense of the complexity of the problem. But for years we've known that we can create and talk about integrated systems and complex systems, but that in no way means that we know how to address the complexities that arise from these systems. So we know how to manage a bit about droughts, hurricanes, floods. We have things in place. That doesn't mean we're doing them perfectly. There's no argument about that, and we're seeing some of that today on our East Coast. But when these issues of multiple changes over time occur, then what we have are surprises in the system, and we have to basically ask how are the services being provided by all of our built and natural systems affecting the interactions of energy, water, and land. So one of the other things that we are more, I think, in this national assessment actually was more so than many ones before it, and it implies us learning over time, is that predict and act methods can backfire in deeply uncertain conditions. When we say here's a projection into the future, just as much as we're saying the past was not stationary, we're assuming some stationary future. And when we do that, and we say, yeah, let's just respond to what the projections are telling us, the uncertainties can be underestimated, there's competing analyses that can contribute to gridlock, and a misplaced concreteness that can bind both the people making the decisions and the researchers to surprises in our system. We're seeing some of those. There's some excellent work in the national assessment and elsewhere showing that we have, the droughts are in fact warmer in many places, and when that happens, we don't simply have dry conditions or extra dry conditions. We're actually seeing things like degradation of ecosystems, the die-off of crops much sooner than we think, and issues surrounding the links between disease, crop yield, and land degradation. So it is important that when we think about adaptation, we're thinking about adaptation in the context of individual operational systems, reservoirs, dams, or electrical grid, and in the context of the broader uncertainties and the interactions of those complex systems. Or as Nostradamus might have said, I did not see that coming. Key message number 3, adaptation entails iterative risk management. Now, this has been happening in the context of adaptive management and watersheds for a long time in the Pacific Northwest and the Colorado Basin and elsewhere. And the issue is that learning over time is the only way we deal with linking risk management to long-term resilience management. When we only talk about the long term, we've known that risk is socially constructed for a long time. The question is how our actions commensurate with knowing that. We act when there are events and create windows of opportunity for acting during those events in which can help us both respond to the event and plan for long-term risks. So adaptation entails learning, iterative risk management, a continuing management process. Individuals and organizations of all types are assessing risks. We know that is happening, and vulnerabilities. They are taking some actions to do that, but there's no one action now that takes care of all of future conditions, and so we know that over time. So it implies an iterative process from our calculated risk or perceived risk, going to complicated risk and the more complex types of issues we were just talking about to create a deliberate or shared understanding of ownership. And what we begin to understand, of course, is as we go from awareness to assessment to planning and implementation and monitoring, each part of this process has to have monitoring and evaluation, the engagement of different partners over time, and I'll come back to that. And this figure is in the National Climate Assessment Adaptation chapter, but it says it emphasizes the idea of what we've learned since 2014, but it does make the point that, in fact, going through the cycle of adaptation implies learning on very different and diverse characteristics of adaptation. It is, in fact, iterative. We learn, we provide feedbacks, and we adjust. A critical question then becomes, how do we choose to learn some ideas over others? Why do we pick some lessons over others in the context of learning over time? And so I'll come back to that. So key message number 4 is that the benefits of proactive adaptation exceeds costs. And this has been proven in a number of arenas. including the changes to business policies, capital investments, and evaluating adaptation strategies needs the consideration, as we know, of justice, cultural heritage, both procedural and distributive justice, procedural meaning how we engage people, the environment, health, and national security. This has been proven over time. So here we have a question in which we've actually shown that the benefits of adaptation, the upfront cost being spent, is actually recovered, even in the near term. And making that point is one of the key things we have to say. But the question is, why, in spite of showing the value of adaptation, are our actions not scaling up in the same way? So we'll come back to that. There's the cumulative cost of sea level rise. As I mentioned, some of these you will have seen before. In earlier presentations, we're aligning those in the context of adaptation compared to a scenario where no adaptation occurs. And as you can see, of course, where adaptation occurs, we can in fact stymie a significant portion of potential risk, up to about $92 billion. If we continue, all right, we lose about $800 billion. So natural hazard mitigation saves lives. This report came out. The ideas behind it played a role in the adaptation chapter. We know that putting in adjustments, building structures, improving our revetments can give us a 5-to-1 return on wind, in some cases a 7 on flood. Hurricane and storm surge, every $1 provides about $7 if we improve our codes, wildland-urban interface. So that's the issue that we've actually shown, and we've learned this over time, that on average, $1 in investment saves us about $4 in long-term risk. So we do have a sense of the upfront benefits, especially for retrofitting and building mitigation methods, also for relocation. But the biggest return that we've seen for managing and adapting to potential risk is in land use planning and design. And the question is, what helps us facilitate improved land use planning and design? And so in showing the benefits of adaptation, I think it's pretty clear. There are other ways of thinking through this. One of the figures that we talked about, the figure is not in the water chapter, but we do describe it in the water chapter. As you can see, this classic sort of diagram, Peter Glick and others had helped put this together, that in 1975, the U.S. water withdrawals pretty much averaged out, but it didn't in fact affect our U.S. GDP. In other words, the issue of efficiency and changes over time actually brought near-term benefits and did not imply a long-term negative cost. This is pretty important. One of the biggest barriers that we identify in the context of what stops us from adapting is the cost. We say, oh, it costs too much to do up front and we'll lose over time. But in fact, the efficient technology at the time, the legal and regulatory demands, and the behavioral changes actually allowed us to get a bit more efficient, even though we doubled population in places like California without negatively impacting our income. But the most important thing is adaptations do not always require major investments. Some very simple things about protecting upland watersheds and so on can be done. The key message 5 is that new approaches can further reduce risk. And what are some of these? Integrating climate considerations into existing organizational and sectoral policies and practices. And the idea of mainstreaming gets us at some of the risk. Some of them are beyond even just mainstreaming. So we need some measure of further reducing the risk of climate change over time. And that's where regulatory and policy environments, cultural and community resources, technology and applications come in. The future pace of adaptation will depend on how effectively social, organizational, and economic conditions support implementation, opportunities for learning, and resilience. Well, we've known this for 40 years in how we adapt and adjust over time. So the lessons are now coming in from disaster risk reduction, the development agencies, and even places like the peace and conflict reduction arena that helps us understand how we mainstream and get at new approaches for risk reduction. So where are we? What is the message? In the context of a changing climate, despite advances today, predicting future hydroclimatic variables precisely remain a major challenge. Even though we do know some things, we know that nature is complex, and we need to improve the reliability of our high-resolution models. Long-term and sustained observation programs are critical, and I can go ad nauseum into that. But the most important thing here is factoring resiliency into system design and planning is still our safest approach. In order to do that, we need regional partners. We need a network of people to help us understand how they're managing their risks and how this feeds into moving beyond single issue adaptation. And this figures in the National Climate Assessment Caribbean chapter. It gives us a sense in the Caribbean for U.S. territories, who else in the region is doing governance, financing, project implementation, advocacy, and knowledge sharing. We have the U.S. Department of Interior Climate Science Centers, the USDA hubs, and the Regional Integrated Sciences and Assessments. And all of them try to function among NGOs, public sector, private sector, understanding the context, innovating services, and providing scientific expertise on the physical and natural systems, on predictions, on projections, and more so, fortunately, on the science policy and decision-making interface. So there are some efforts to help us understand in different regions how to treat adaptation as an iterative process. So that leaves us with some of our remaining challenges. The risks of underestimating the complexity of adaptation, even though we are advancing extremely well in many areas. There's increasing recognition of adaptation buffers arising from ecosystems, but very little commensurate action to support this awareness. Our coordination and implementation across the scales of governance, as yet, there's unclear responsibilities of the actors, conflicting timescales of interventions and response. And one of the biggest barriers is the limited community acceptance of those adaptations that are needed. And one of the reasons why that is that adaptation and resilience are not seen as representing absolute goods, actually goods that form the basis of human security. We see them as add-ons, we see them as extras needed on providing water, energy, food, and so on. And we have not made the case that adaptation itself or resilience itself is an absolute good. And as a result, we see the flow changes, the rapid changes, the effects on ecosystem services, and what I'm basically pointing out is that this gives us a sense of the complexity that is engaged in doing adaptation effectively. To begin to wrap up, one of the things I wanted to put this figure here, one of the people who was on the adaptation chapter, Dale Sands, worked at AECOM and CH2M Hill for a while, and we worked together with the UN, used to be called the International Disaster Risk Reduction. It's now the Office of Disaster Risk Reduction. This figure gives us a sense of the time frames, the types of risk assessment that corporations do, the preposition of supplies, event tracking, and the idea that adaptation is inherently cross-timescale. There's no single adaptation that takes care of all time. And this applies to the public sector, the private sector, the non-governmental sector, and communities. So resilience spans multiple activities and timescales. To summarize, adaptation implementation is increasing. It entails iterative risk management. Change is outpacing the rate at which we plan and implement. We know that the benefits of adaptation exceeds costs in most cases, and significantly so in many cases. Introducing new approaches for helping us deal with rapid changes and thresholds are available, but we haven't been able to scale them up beyond the project level. And challenges remain for adaptation and on, not just to do adaptation, but on adaptation itself. The provision of standards, explaining the co-benefits from other actions such as disaster risk reduction and ecosystem management. So the challenge remains to broaden the actor network. And what I mean by that is beyond just users of information to the transaction brokers, the local conveners and advocates, investors, and the beneficiaries of those investments, the tools, the suppliers, philanthropies, and private capital, in addition to the agencies and academia. Sustaining collaborative networks across research, observation, services, and decision-making as changes emerge, new knowledge emerge, and changes occur over time, and windows of opportunity open is critical. As I like to say, bad ideas have windows of opportunity too, and we have to be ready to act in the context of change. There's an old Chinese figure. Some measure of order, together with our interaction with the natural system for a long time, when you put them together, it's called political order in ancient Chinese characters. Thank you.
Great. You went through an awful lot there, Roger. Thank you so much.
Yes, it's a complex chapter.
It is.
Yeah.
I'm amazed you got through it that quickly.
Mm-hmm.
Julie McNamee has a question. She asks, I believe that the benefits exceed the cost of implementation of adaptation. but the sticking point is what's the time interval until we see the benefit?
Right.
Has there been work to define how soon we can see the benefits for the cost? How long
This is a great question because this relates to the question I mentioned that, we place an upfront cost and we use, sometimes that upfront cost seems too large because it's a dodge because of discount rates and everything else, the time over which a dollar loses its value. One of the arguments we're making is this, that unless the tools, the techniques, and so on, from ecosystem management, from disaster risk reduction, are also linked to adaptation, we're still making an arbitrary distinction between the risk of dealing with near-term events and the long-term planning that's needed for adaptation. From our standpoint, the reason why adaptation is iterative is that it has to help you next season, next year, in addition to the next 5 years, 10 years, and down the road. And if we do not, then we run into exactly the problem that she's identified, which is that the benefits seem somewhere off too far in the future. The moment we do that, not just, even people with good intent will defer the actions taken. As people have heard me say before, I like to say in meetings like this, people will say, let's be proactive, and I will say, yeah, you first. And the reason is that means it implies an upfront cost of personnel, time, or money. So unless we can, in fact, show that the adaptation, the introduction, and the interventions, and the partnerships help us with near-term risks, hurricanes, droughts, floods, other things we're experiencing, land degradation issues, within the near term, the point being made will always be a sticking point for why we do not implement adaptation. A couple major reasons we see is the upfront cost, and sometimes adaptation can be daunting. It seems too complex to implement into the long term. The real issue there is that we have to be able to show that we're learning from the near-term events on how we adapt and adjust over time. So linking risk and resilience is, I think, how we get past that barrier, but it is a real barrier.
I wrote that down. That's such a good thought. I'll keep that in my head. Okay, so we're ready for our next speaker. Thank you so much, Roger. And we're going to move on to Jeremy. Jeremy, take it away.
Okay, great. Can you hear me all right?
Yes, fine.
Great. All right, thank you very much. I'm going to talk about the highlights from the Chapter 29 on reducing risks through emissions mitigation, which is more commonly known as the mitigation chapter. And I'll start by saying we're using mitigation in a slightly different sense here than how Roger was using it. In this context, we're talking about emissions mitigation, or reducing greenhouse gas emissions and the effects that may have. So let me first start by saying I was joined on this chapter by just a wonderful cast of co-authors. I won't read them out here, but you can see them. A lot of diverse interests just brought an immense expertise and experience to this effort, something I was very honored to be a part of. Actually, let me go back for a second. The team itself was tasked with somewhat of a challenge in that there's a lot of really interesting climate mitigation questions that certainly were posed to us, and would maybe an NCA4 reader would expect to see everything from, how much are we emitting, to what are we doing to reduce those emissions, to what are the policies on the books or future policies that may be necessary to achieve specific climate goals. Are these policies enough? What types of roles do climate intervention or geoengineering play in those policies? What are the impacts under future scenarios? Just a ton of questions that quickly would blow up a chapter focused on mitigation in the NCA4. And so what the NCA4 steering committee directed the chapter team to do was focus primarily on 3 topics, and those 3 are the covering a state of mitigation, what is happening within the U.S. With regards to emissions mitigation. Point number 2 was characterizing the risks of inaction on climate change. So without emissions mitigation, how would risks change in the future across impact sectors of the U.S.? And point 3, how mitigation can reduce those risks. And so, and then, in other words, if we reduce greenhouse gas emissions, that may lead to a reduced level of future climate change. What is the science? What are the studies supporting what we know on how those risks may change and how we may be better off as a result of that emissions mitigation? And so there's a couple other topics that this chapter team discussed. There's a short section on climate intervention and geoengineering. Mostly we point to the chapter of Volume 1 of NCA4 on mitigation. So there's just a lot more detail there on that topic. And also, as I will discuss a little bit, we get a little bit into the interface of adaptation, which you just heard from Roger, and mitigation. And so with that, I will move along. So our first key message, again, relates to this: what is going on? What is the state of mitigation? And like NCA3, we have a key finding regarding the level of efforts that are being taken, certainly compared to where we were in 2014 when NCA3 was released. There have been just an explosion of additional efforts at particularly state and local levels and in the private sector to address greenhouse gas emissions. Those efforts are increasing and deepening. I'll toggle here to the next slide, which shows figure 29.1 from our chapter, which highlights efforts being taken at state and city levels. Certainly there are efforts being taken at other political levels, counties, multi-state regions, and then federal policies as well. But I will, say that broadly, that we found that there are significant activities happening across, all sectors of the economy, dealing with, transportation, stationary source, electricity generation, energy efficiency programs, and so forth. And so, maybe the second takeaway I'll mention is that despite so much happening, these collectively these efforts do not, approach the scale needed to avoid, the worst climate impacts that are projected for the future. So, the takeaway is there's a lot happening. It's just not enough. So I'll transition to the second key message here on the risks of inaction. So this is again in the absence of additional efforts to reduce emissions in the U.S. and across the globe. Climate change is projected to impose substantial damages on the U.S. economy, human health, and the environment. Those words were very carefully chosen and particularly meaningful. There's been, and this chapter benefited from really a significant expansion in the climate science literature on quantifying across sectors of the economy, specifically the U.S. economy, impacts and sort of both in terms of changes in physical effects as well as economic valuation. And so there's some work that has been done by a group called the Climate Impacts Group, formerly the Risky Business Project. There was an effort that has now, I believe, disbanded, but formerly led out of the National Center for Atmospheric Research, or NCAR, and their BRACE project, as well as some efforts at EPA that I'm involved in called the CIRA project. And so these three efforts have, all undertaken sort of multi-sector impacts modeling. There's, of course, a pretty deep literature on, sort of climate impacts on individual sectors and beginning to, quantify those impacts across scenarios and, as well as monetize those effects. And so there was a lot that has been, published in the past couple of years that this chapter team could rely on in releasing this chapter. And that literature really helped us address two gaps that the national academies and the Board of Atmospheric Sciences and Climate, which sort of advises and provides recommendations to the USGCRP in developing the National Climate Assessment. Two of those main gaps coming out of NCA4 were that the USGCRP should try to characterize risk, the benefits of risk reduction more thoroughly and in more quantified ways, as well as begin to describe the sort of economic implications of climate change. And so, as we addressed the three tasks given to us by our federal steering committee, we tried to make some advancements in our coverage of those two gaps. And so I'll maybe say a little bit more on this risks of inaction slide by saying that the team was able to draw out a number of studies which suggested significant economic impacts of climate change in this higher emissions scenario, and that many of these impacts can be irreversible for thousands of years, and some may even be permanent. So sort of a future where emissions mitigation is not undertaken spells more significant impacts to the economy and human health. Following on that, the third key message is sort of the flip side of that, and then the consideration of, well, if we do reduce our emissions under a lower emissions scenario, in this case RCP 4.5, which was the prime lower emissions scenario considered in NCA4, what are the benefits? What does the literature suggest as being the benefits of those emission reductions to the U.S.? And so I'll pause and reiterate that this is global scale emission reductions, but specifically a consideration of how the U.S. may benefit from those emission reductions. And so the literature suggests that the team assessed the literature and found that there are significant benefits of those emission reductions to the U.S. Many risks can be reduced, but the magnitude and timing of those avoided risks vary by sector and region. So there are some sectors, particularly, for example, those related to sea level rise, where the effects of emissions mitigation are really not realized in sea level rise scenarios until later in the century, past mid-century. The result is that the effects of emission reductions are not realized quite as much in terms of reduced risks from sea level rise. That may show up when you look at time horizons beyond 2100, but the literature we suggested, or that we reviewed, suggested that some sectors may have smaller benefits, some may have very large benefits of emissions mitigation. And so this next figure in our chapter 29.2 tried to pull together some of the multi-sector impact work coming out of a single coordinated modeling project, in this case the CIRA project, which tried to estimate these impacts across sectors in a very coordinated and consistent way, such that the inputs and assumptions are standardized so that you get more apples-to-apples comparisons across sectors. And there's a lot going on in this figure and table, and so I won't try to get into it all. But you can see that this literature has advanced from where we were with NCA4, and that there's a heightened level of sort of monetization and quantification of these impacts across sectors. There's a sort of a detailed story behind each one of these circles, and sort of the underlying methodology and modeling approach that was put into that particular study. And then, of course, all of them together provides a sort of its own sort of storyline that would take an entire hour just to convey. But some underlying maybe some takeaways here are that some sectors, particularly those related to public health and human health, can have very high damages by the end of the century under a higher emission scenario. Some of those damages creeping into the hundreds of billions of dollars per year. And for some of those sectors, you can see in the lightly shaded part of the bubble you can see the effect of the projected effect of emissions mitigation. So how much of those projected damages under the higher emission scenario could be reduced as a result of lower temperatures or a smaller amount of climate change under the lower emission scenario. So for many sectors, that effect is roughly 50% or more. And so, I expect to see, continued advancements in these types of studies, improved methodologies for all of the underlying modeling that goes into projects like this. So, hopefully that will help us better constrain some of the uncertainties and improve our confidence in being able to talk about these economic vulnerabilities in more certain terms. So similarly, here's a sort of a related figure coming out of a different study, this one from the Climate Impacts Group, and a paper they released in 2017 in the Journal of Science, where they had assessed impacts across 6 sectors and considered 3 emission scenarios or forcing scenarios. The red and blue ones were the 2 RCPs that were the primary focus in NCA4, but essentially with showing sort of the global carbon emissions on the left and the direct damage to the U.S. economy on the right, as consistent with what I stated before. There are larger observed macroeconomic damages projected to the U.S. economy. Under a higher emission scenario, you can see that variability also increases significantly. These are damages on that y-axis of the right panel in context of current U.S. GDP or gross domestic product. So you can see that we're talking about some pretty significant damages owing to just consideration of 6 sectors of the U.S. or 6 specific impacts to the U.S. and those were for agriculture, crime, coasts, energy, heat mortality, and labor. So to kind of tie it into Roger's nice overview of his chapter, we have a key message in a section in our chapter that talks about the interactions between mitigation and adaptation. For a long time, the NCAs and other reports have shown and documented that there's a clear interaction and importance consideration of the two, and sort of a consideration of dual strategies as approach to responding to climate. And we found instances in literature supporting that the 2 strategies can complement each other in substantially reducing exposure and vulnerability, and that some of this sort of complementarity is especially important because, like I said before, for many sectors, the effect of mitigation may be reduced due to sort of momentum and delays in the climate system, such that even significant emission reductions, if they were to be taken today, won't be realized for decades because of momentum in the climate system. So as a result, this is a key finding, sort of underscoring the importance of very near-term adaptation in concert with very near-term emissions mitigation. So lastly, I'll just conclude on some research needs. The chapter wanted to point out, again, these advancements that we benefited from, and in being able to draw upon a level of a discussion of risk reduction and quantifying and monetizing climate impacts in the future under alternative scenarios. But more is needed. A lot more is needed. Not only do we better need to understand, impacts are happening across sectors that have yet to be explored, but it just in improving our ability to estimate those impacts and reduce those uncertainties, incorporate adaptation. So, specifically being able to model, the sea level, the sea is rising. It's going to affect coastal property, but we need to be able to estimate how we may respond and how we may adapt to those risks. Yes, emissions mitigation may reduce the ultimate level of sea level rise that we experience, but we know we will respond somehow, either by protecting, accommodating, or abandoning coastal property. So all of those options have economic implications, and those are important to the dialogue. We found that there's still important gaps on social vulnerability and exposure. So we know that impacts are not spatially distributed evenly across the U.S., and certainly they're not evenly distributed across populations of varying social vulnerability. So that is an additional angle that needs to be incorporated into these studies, and for the most part hasn't. And then an improved understanding of sort of avoided and increased risks of thresholds, tipping points, and irreversible outcomes. Sort of these lower probability but high impact events are still, many of which are poorly understood, but it could have very significant implications for the ability of emissions mitigations to reduce risk, but also the ultimate economic effects of climate change on the U.S. And so I will stop there. But thank you very much for this opportunity.
Great. Thank you, Jeremy. And we have a question for you right there. It's from Sydney Fishman. Said, can you talk a little bit more and maybe give examples about the potential consequences of mitigation and adaptation interacting?
Yeah, it's a good question, and we summarized a couple in the chapter. One example I can think of is that, and this kind of reminds me I should have reread that section, so I was extra sharp on this topic. But think of land use change would be the good example. So in a scenario where in order to reduce our future emissions, we the agricultural system relies even more on the use of land for the production of biofuels. That may cause effects not only on the food system, but it also could constrain water resources and could constrain our ability to use water to adapt to water that is maybe necessary in order to grow those crops and grow that corn that is being used to develop ethanol. So we may sort of need more and more biofuels to meet our climate mitigation targets, but as climate change perhaps changes drought patterns and changes the magnitude and frequency of drought, that may influence our ability to adapt to that drought by, say, increasing the water availability for irrigation. And so that's kind of the example I can think of the most. But there's other examples with regards to energy efficiency and heating and cooling demand. The more that you warm the planet, the more air conditioning we will need. That, of course, creates more electricity demand, and generally leads to an increase in emissions. So there can be positive and negative interactions between both mitigation and adaptation.
Okay, thank you, Jeremy. And then we had a question from Josh Foster. How do we embed or mainstream climate adaptation into other professional cultures or networks largely driving our economies, e.g. planners, architects, insurers, financiers, developers, etc., who may not have climate or adaptation as part of their professional development track or have a different view of risk? Do you want to take that, Roger or Jeremy?
Sure, I'll give it a shot. Hey, Josh. So this is in the context of what I mentioned about broadening the actor network. The idea that, in fact, professionals who take the risk of trying to get the issue of climate embedded in their practices, whether it's everything from water to tourism to agriculture, are in fact taking a professional risk. If we do not have a broad-scale acceptability of the training and standards needed for people to engage in their own agencies and corporations. So what I mean by that is there is no amount of presentation, lectures, and report that beats having a few individuals within those agencies and organizations seeking change. Our goal is to ensure that what we're doing is providing the right training and capacity needed for those individuals to act. Jeremy was just on an extremely rich point about the issues linking adaptation and mitigation, especially concerning how this happens in the context of food production, energy required, water required, and then the positive consequences of efficiency and long-term planning. In that setting, what is needed more than anything else are people with the background that we are trying to provide through the assessment, trained in doing vulnerability and capacity assessment and the use of information in planning and risk management, who are actually embedded in those agencies and practices. Otherwise, we will still have a gap and assume that simple communication is all that's needed, when in fact what you need are individuals embedded in those organizations willing to take the risk to make change. We call them, for want of a better phrase, policy entrepreneurs. So that's the only time we've seen such change happen.
Okay. Thank you, Roger. We have another question from Sarita, who asks, what is the best modes to educate the public on these risks and benefits of mitigation? Are there organizations that are doing innovative work around this topic? Who would like to take that?
I think Jeremy would.
Yeah. Maybe I'll first say that I don't have a good answer to that. I do think the sort of benefits of, the quantified and monetized benefits of mitigation is a pretty sort of nascent field. The science is only just now kind of coming out over the past couple of years on this stuff. So, but I will say that the economic storylines from NCA4 were very popular, and maybe Katie can confirm that for me. But in the press coming out of NCA4, a lot of the attention seemed to be focused on what NCA4 was saying with regards to economic impacts and economic implications. So, it seems that is a dialogue that, not surprisingly, rings true to people who are concerned about climate change, or people who may be on the fence but want to know, how, is climate change a big deal or not? Well, scientists and economists need to, provide information, on what, on what is at risk, and that is very much an evolving field. But in terms of the best modes to sort of educate the public, certainly, the NCA4 website, and sort of all the content of NCA4, there's a lot of great graphics of, syntheses of, what are some of the latest and greatest sort of studies that are beginning to quantify this information. There's some work, one of the chapter authors on the mitigation chapter, Brenda Eckwurzel, I know her group at the Union of Concerned Scientists has been doing a lot of work on trying to expand this sort of risks of or risk of inaction and sort of benefits of mitigation storyline. So she may, you may want to check in with her with that question. I bet she'd have some ideas.
If I could just add a quick corollary, the part of the issue is being able to show that, and it relates to the question I was asked right after my talk, being able to show that there are in fact actions people can take place, and we're trying to make a statement that they're better off for doing so, for engaging in those actions. But those benefits have to be, one, near term, and two, there should be clear pathways for how people get engaged. That, I think, in trying to get at why, what the World Bank calls the triple dividend, the fact that you're not simply avoiding losses, but you're getting the benefits of having avoided those losses, the economic, the social components of them, making that case has not been as clear. It's one of the reasons why things like the Regional Integrated Sciences Assessment, the Climate Science Centers, and the hubs were created. But we need to very much scale those up to the size of the nation itself in order to create, what people have called different communities for how we understand risk, how we share, beyond trivial notions of co-production, how we share our sense of the risk, but also where we get together to make those risks transparent and to act on them, economic, social, and otherwise. So from the mitigation standpoint, which always seems to be the toughest because of issues surrounding energy and so on, the idea that we can in fact show near-term gains from upfront efficiency and investments is critical. But then taking that information in the context I just described in a broader actor network to help people understand why they're better off for doing that. You're not just lecturing them on doing the right thing, but in fact it's to their benefit. I think that's where these sort of regional robust networks come in. So.
Yeah, and this is Tracy. I just want to say I see a lot and hear my neighbors talking about stuff they hear from NGOs and just science writers in the newspapers. So it seems like there is a lot out there on this.
There is a lot. I think what Jeremy was also getting at is there's a lot, and there's an issue of standards as well.
Oh, right. That's true.
Yes.
Okay. Well, if there aren't any other questions, I do want to take a moment to thank Katie Reeves, who put a lot of time and effort into making this happen. She created this massive spreadsheet for me with all the information that we had to put out to promote this. She provided great slide kind of backgrounds for everybody. She made this really a lot easier for everybody, and I want to really thank you, Katie, for doing that. Did a terrific job.
Well, thank you, Tracy. This has been a really great experience. I would just, if I can, just take a second here as we wrap up. First, thank you, Roger and Jeremy, for these excellent presentations. It was really a great way to close this out. And thank you to everybody who's on the phone with us today. We had a great group of about 100 people. To those of you who've listened to all of these webinars, and I think there are a few of you, we're so happy that you spent your Tuesdays with us all summer. We made it to the end, and I hope that you found all of these webinars interesting and valuable, and that they presented something of a window into the contents of Volume 2 of the assessment, and to all of the hard work that went into developing it. And there were more than 300 authors who volunteered their time and energy to do this, and we're so proud of it. And finally, just thank you again to NOAA, and especially to Tracy for hosting us on this. It's been a really great experience. So thank you so much, and take care.
And one last word, I just want to say that all these recordings and PDFs for all these talks are available on the website that Katie has posted in the chat box. So if you want to spread the word wider, like say there's a particular chapter that really moves you, or something you understand, or the graphics were just outstanding in this presentation and in the report. So please spread those widely. And Roger and Jeremy, thanks again for all your hard work, and thanks for presenting today. Thanks for joining us, everybody.
Great, thank you.
Thanks.
Thank you.
Bye-bye.